Hi, and welcome back. Today's lesson is 1.5, more with domain and range. So because functions convert values of inputs into values of outputs, it is natural to talk about these sets that represent these inputs and outputs. As defined in prior lessons, the set of inputs that result in an output is called the domain, and most of the time we call them just the x values. And the set of outputs is called the range, which are the y values. So in exercise 1, state the range of the function f of n equals 2n plus 1 if its domain is the set of 1, 3, and 5. Show the domain and range in the mapping diagram below. So if you have x is equal to 1 and our function is f of n, so we're going to do 2 times 1 is 2 plus 1 is 3. I can do my math. All right, so 3 times 2 is 6, plus 1 is 7. And 5 times 2 is 10, plus 1 is 11. So that's simple enough to do. Take a minute, write that down. Show the domain and the range in the mapping diagram. Okay, so the domain here, so why don't we do a set notation? So we'll say domain is 1, 3, and 5. And the range is going to be 3, 7, and 11. Now, when you're in set notation, remember that order doesn't necessarily matter. So we're math people. We tend to do things in order, but it's okay to do 7, 3, 11 as well. Okay, so in exercise 2, the function y equals g of x is completely defined by the graph shown below. Answer the following questions based on this graph. So A, determine the minimum and maximum x values represented on this graph. So when we're talking about domain and range, especially when you have a domain and range and you have a finite domain and range, it's kind of nice to put a box around your maximum minimums. So as we can see, we started with the topmost point, and that became our upper line. The bottommost point became the lower line for our range, and then the same thing goes for our domain left and right. So the most left point will be our left-hand line, and the most right point will be the right-hand line, and they don't necessarily always have to be the same. So determine the minimum and maximum x values represented on this graph. So we're going to write this in 2 different ways. We're going to write it in set building notation. Oh no, I'm sorry, I'm getting ahead of myself. That's down at C. Just maximum minimums. So what's the minimum x value? So let's see where that minimum x value is going to be. It's going to be right here at x equals -3. All right, and how about the maximum? Same thing. Remember, the domain kind of cuts it sideways. So that's going to be at 6. And we're going to do the same thing with the range. Determine the minimum and maximum y values represented on this graph. All right, so the minimum would be the lowest point, which would be 1, 2, 3, 4, 5, -5. And the max would be the topmost point, which would be 1, 2, 3, 4. Okay, so C says now state the domain and range of this function. This is the question I wanted to answer at the beginning. So we're going to answer this in 2 different ways because it doesn't ask us which way. And if it doesn't, we get to choose. But we're going to talk about both ways. So if we're going to talk about the set building notation and we're going to talk about the domain, when you use set building notation, we start with the minimum, which is -3. We always use less than or equal to's. In this case, we're going to use x because x represents our domain, less than or equal to, and the maximum, which is 6. And how we read this is x is kind of sandwiched between -3 and 6, or you can read x is greater than or equal to -3 while it's less than or equal to +6. Okay, now we're also going to do interval notation. Interval notation, when you have the less than or equal to sign, that's going to be a square bracket, your minimum number, comma, your maximum number, and then another square bracket. If this was a strictly less than sign, you would have a parenthesis, which we not using in this case. All right, so right, all right. So, but we're not using that here. Okay, so range, we're going to do the same thing for our range. And we're going to represent it both ways. First in set builder notation. So minimum, which is -5, less than or equal to y this time, less than or equal to our maximum, which is 4. And we can also represent it in set builder notation. Same thing, square brackets, minimum, maximum, and square bracket. Now, sometimes when we start getting into things a little bit more complicated, instead of writing y, we write whatever the function is. So I think this function was g of x. So we could write this as -5 less than or equal to g of x less than or equal to 4. So that's just another way to represent the range. All right, so write down what you need to and meet me at exercise 3. Some functions defined with graphs or equations have domains and ranges that stretch out to infinity and are represented with arrows at their endpoints. So sometimes you can't put a box around it. If you look at this parabola in exercise 3, we could probably put a line at the bottom, but we really can't put a line at the top because we have arrows there. And it's the same thing when you think about our domain. We have arrows, so you can't put lines on the right hand side. So that kind of gives you a hint that that's when infinity is going to come into play. So the function f of x equals x squared minus 2x minus 3 is graphed on the grid below. Which of the following represents its domain and range written in interval notation? So multiple choice, it's giving you interval notation. So we have to figure out which one is the correct answer. So, domain. Well, if you think about drawing a line, anyway, just this way, vertical line. Is there any place that we can move this vertical line where it would stop in either direction? And the answer is no. So, this case, our domain is going to go as far as it can to the left, which we refer to as negative infinity, and as far to as the right, which we mean positive infinity. And sometimes we'll say the domain is all real numbers, but if you're writing it in interval notation, how we write that is negative infinity to positive infinity, and we actually surround it with parentheses versus brackets. All right, so now if you look, it's the only one that has that, but let's discuss why the range is -4 infinity. So if you think about cutting it horizontally, like we showed this one line on the bottom, it starts at -4. That's our minimum. And as we take that and we start going upward, there's actually no place to stop this. So this is not going to end at all. So that's where that positive infinity goes. It's going to keep going and going and going. So hence the reason our range is bracket -4, because it includes -4, up to infinity. So number 3 is our correct answer. Okay. The following exercises are examples of domain restrictions. Exercise 4 shows a fraction, and we know that when the denominator is equal to 0, the fraction or function is undefined. Exercise 5 shows a square root, and in mathematics we cannot take the square root of a negative number. We'll discuss that a little further in class. So exercise 4 says the function f of x equals 2x plus 1 divided by x minus 4 has outputs given by the following table. And you can find this on your calculator very easily. So evaluate f of 1 and f of 6 from the table. So f of 1, remember in that case, f of 1 means that that's the x value, and they want us to find y. So f of 1 is equal to negative 1. F of 1 is equal to negative 1. And f of 6 is equal to 6.5. Okay, so now why does the calculator give an error at x equals 4? And actually in your calculator it would say ERR. It wouldn't say error exactly. So when you see ERR capitalized, you'll know that that's an error on your calculator. So hopefully you're remembering that in your denominator, when you have x minus 4, let me circle up at x minus 4, and you know that that will be undefined when that's 0. So when x is equal to 4, we get a denominator of 0. Don't care what's going on upstairs in the numerator, but the denominator is 0, so that's going to give you an error there, which means it is not defined at x equals 4. All right, so why does the calculator? So let's write that out. Let's write out that what are we writing out? At x equals 4, our denominator is equal to 0. So the function is undefined. Okay, I hope that makes sense to you. I'm just going to give you another minute to write that down. So C says, are there any other values or any values except for x equals 4 that are not in the domain of f? And it says explain. And if you had this in your calculator, you could go up and down the list and you wouldn't find any other errors anywhere because this is the only domain restriction. So we're going to say no, there are no, not. There are not. There we go. Okay, let's move down. Exercise 5. All right, which of the following values of x would not be in the domain of the function y equals x, the square root of x minus 4, and explain your answer. So this isn't just a multiple choice, it tells you to explain. So y equals x plus 4. So what do we know about square roots? So we can talk about this a little bit. If we think about the square root, think about what the definition of a square root is. Square root is you're taking the square root of a number, so you're looking for two numbers, the same numbers, that multiply together that give you that number under the square root. So is it possible to get a negative under there? Is it possible to get a number that you multiply by itself and get a negative? Hopefully you're saying no, that can't happen. Because even just thinking about the signs, if you have a positive times a positive, you're going to get a positive. And if you have a negative times a negative, you're also going to get a positive. So no matter what, you cannot get a negative under that square root. So x has to be greater than or equal to, it can be 0. All right, so it must be greater than or equal to. All right, so it has to be greater than or equal to 0. So in this case, we can set up a little equation, and we can say x plus 4 has to be greater than or equal to 0. So let's go back to Algebra 1 and apply our properties of real numbers and minus 4 from both sides. And we get x is greater than or equal to negative 4. All right, so that means that x can only be negative 4 and above. And don't think just integers. It can be any number that's greater than or equal to negative 4. So it says which of the following would not be in the domain? So which one wouldn't be? All right, because negative 8 is less than negative 4. It's the only one that, and think about a number line, how a number line works. Because sometimes when we get those negative numbers and we have to compare them, just figuring out if you put a negative 4 down there, like what numbers, like where does 0 fall, right? 0 falls there, so we know that's okay. 5 falls all the way over there, which is still okay. Negative 3, you would think sometimes negative 3 falls to the left, but it doesn't. The only one that falls to the left is that negative 8. All right, so believe me, they confuse me too once in a while using a number line. Nobody will judge you for it. I think we're done. Is there an exercise 6? I think that might be it. Nope, that's it. So we're good for today. We are at 16 minutes. Woohoo! And we will finish the independent practice in class tomorrow. So until I see you again, always make good choices. I'll see you next time. Bye-bye.